Well, hello viewers, my name is Quinton Beckett from Portrex Technical High School, and today we are broadcasting live from ECDoE Broadcast Studios. Today's lesson is all about Euclidean geometry, and I just want to simplify it for you so that you get a better understanding of this section. Just as we said earlier, we are going to be looking at Euclidean geometry today, and like any other subject, you need to know the rules before we can actually look at answering some questions. So the first thing that we're going to do, just like a rugby match, we are going to learn the rules first, and then we are going to answer some questions in Euclidean geometry. The first rule that we need to look at is we need to understand the parts or the different parts of a circle. And as you can see on the slide that we have here, just select my laser pointer, we can see that the circle has many different parts. Let's start off with an arc. Now, as I said before, what I want to try and do in this short lesson is that I want to try and put across technical terms in a way that you can understand. So firstly, an arc is a part of the circumference of a circle. So what we're looking at is this over here is our circumference, right around the edge of the circle. But the arc would be that little point over there, or it could even be this point over here. So that is what the arc of a circle is. A radius is any straight line from the center of the circle to a point on the circumference. So if we have a look here, here's our straight line, and we go from our center of the circle, there's our center, and we go right through to the circumference. Remember, matrix, that this over here, the diameter, that is also, that straight line over there from the center is also a radius. So don't get confused about that. Now we look at the diameter, and please be careful about this. The diameter, as the diagram would say, is a length of a straight line segment from one point on the circumference to another point on the circumference that passes through the center of the circle. Please be aware, it's going from this side of the circumference. It is a straight line. In other words, you cannot go from the circumference here to the center of the circle and then go off on a tangent down here. So in other words, let's just put it in a color that you can see. You cannot go down like that. That is not a diameter. A diameter is a straight line from one side of the circumference through the center to the other side of the circumference. So please make sure you understand that. A segment is part of the circle that is cut off or is created by a chord. So if we have a look at our drawing, laser pointer up here. If we have a look at our drawing, here is our segment over here. So here's our chord, and there is our segment, our section of the circle that has been cut off by the chord. Tangent, if we have a look at our circle again, the tangent is not inside the circle. The tangent is actually on the outside. Whoops, sorry about that. Our tangent is on the outside. So that yellow line over there that goes across, that is our tangent. And the tangent, what's special about our tangent is that the tangent touches the circle at only one point. Very important. It does not touch it anywhere else except for one point. If it touches at 2 points, this is called a secant, a line that meets a circle in 2 points. So be very careful about that. As we can see here, this chord would be a secant because it touches the circumference of the circle here all the way across, and it touches the circle over there. If we have a look at a sector, here is our sector in red, over there. And a sector, what is the difference between a segment and a sector? Well, the big difference is a sector is made up of two radii, there they are, whereas a segment is made up of a chord, and there's our chord over there. And last but not least, let's talk about the circumference that we were talking about. So our circumference, there it is, like we said, it's the round part all the way around the edge of the circle. And think about it this way. If you had to cut this line, this circle, and stretch it out to make a straight line, if we measured that linear point from where we cut the line all the way around, all the way around, that is your circumference. So now that we've got the basics of a circle, let's move into looking at some of the theorems that you have learnt from grade 11. All right, matriculants, if we have a look at our first theorem, and this will be one of three, the first theorem that we're going to be looking at is called the arrow theorem. Now, why do we call this the arrow theorem? Well, for the simple fact that when we look at the shape that the chords make, we can see that there's a clear arrowhead that is formed, as you can see there that I've highlighted on the drawing. So that is why we call it the arrow theorem. Now be very careful. In your exams, you are not allowed to use arrow theorem as your reasoning behind why a specific angle is equal to another angle, or why a specific angle is half of another angle. Your examiner, the examiners will not give you your marks. Please, you need to write down the correct theorem. The arrow theorem is the slang word, if you want to call it that, is also known as the inscribed angle theorem or the central angle theorem. And it states that the measure of a central angle, the angle that is at the center, let's just go back there. So the angle that is at the center, the central angle in a circle, is twice the measure, is twice the size of the angle, of the inscribed angle, subtended by the same arc. In other words, in its simplistic form, what the arrow theorem is saying is that this angle in the middle, this 2x, this angle here, the central angle, is twice as big as the angle at the circumference. In other words, if the center angle or the central angle is 2x, the angle at the circumference is x, and vice versa. If the angle at the circumference is x, the central angle is 2x. Please, like I said before, do not forget, you cannot write down arrow theorem as your reasoning. You will not get your full marks in the examination. Moving on, we have our second theorem, and our second theorem is the bow tie theorem. Now, why do we call it the bow tie theorem? Well, if we join all our lines up again, as you can see there, you've got a bow tie, a very snazzy one at that. So the bow tie theorem, which is also known as the angles in the same segment. Okay, so angles in the same segment. Now remember, angles in the same segment. We spoke about segments earlier. Have a look at the segments. Have a look at the angles that are the same. Let's change the color here. Here we have an X, here we have an X, and here we have a Y, and here we have a Y. So angles in the same segment. It states that the angles subtended by the same chord in the same segment of a circle are equal. In essence, if two angles both have their vertices on the circumference of a circle and both see the same chord, then those angles are equal. This theorem, like I've said, is informally called your bow tie theorem because it looks like that bow tie. So all that jargon, all that mumbo jumbo, if you don't, or if you haven't heard anything that I've said, forget about that. Remember, these are bow tie. Angles in the same segment. So angle X over there is going to equal to angle X over there. Similarly, angle Y down at the bottom here is also going to equal to angle Y over there. Matrix, when you are answering questions, just remember, like the arrow theorem, that the bow tie theorem is the slang word for this theorem, angles in the same segment. The reasoning when you are answering your questions, you will put down angles in the same segment. Moving on, we are looking at a tangent perpendicular to a radius. So here, remember, we have a tangent, as you can see, the tangent on the outside in green, it touches the circle only at one point. There it is there. Only at that point. And a tangent line to a circle is always perpendicular to the radius drawn to the point of tangency. Let's try and simplify all of that. Here is our tangent line, and we've said that the tangent line only touches the circle at one point. There it is. If a line is drawn from the center of the circle and moves through to that tangent line, the angle that it forms over there, that angle, let's actually change that color. That color doesn't look great. It's the blue, let's put it in red. Let's go red. That angle that it forms there is 90 degrees. Now be very, very, very careful about this. There is a specific rule that we have mentioned here. We have spoken about a tangent line. There's our tangent line. We have also spoken about a radius line, a line that goes from the center of the circle and goes to that tangent line. That is when the 90 degrees is formed. The question that I have, or could be asked, is what happens if that line or that chord doesn't go to the center? It sort of goes off on the side. Well, then surely the angle that it forms over there, surely that's 90 degrees as well. Matrix, it is not. Be very careful. The parameters of the question or the parameters of the theorem are set. It must go from the center through touching the tangent, and that will cause your 90-degree line. Please make sure that you understand that. Please make sure that you get that right. Too many times I've been marking, and I see that learners just straight away say, oh, it's a center radius, the line from the center all the way to a tangent, and it's a radius, therefore it's 90 degrees, or they'll say that there's a line that's going from the circumference and it's going to that tangent. Definitely it's 90 degrees. No.
Go back to you stating what you just stated, but to the camera now so that I can get to you.
Oh, okay.
Yeah.
Okay,
So
this.
can you say it to the camera?
Okay, perfect. Okay.
And action.
So matriculants, please be careful in the exams. The rules state that the line needs to go from the center, or the chord needs to go from the center of the circle through to the tangent point. This forms your 90 degrees or your perpendicular line. If the line goes from the tangent point to the circumference, please do not assume that it is 90 degrees, because it will not be. It does not meet the rules or the conditions. Please, there are many, many times that I've seen in an exam where learners simply just say, this line or this angle is 90 degrees. Why? Because it's a tan chord. Be very, very careful in your exams when you see this theorem. Moving on. Tangents to a point outside of a circle. So now we're starting to move outside of the circle. No more looking inside, we're now starting to look outside. So here we have our circle, and let's change the color up a little bit. Here we have our circle, and we have two tangent points, one in blue there and one in red. As you can see, these two lines, these two tangent chords, run to a common point outside of the circle. If a tangent or two tangents meet outside of the circle, this tells us that these two lines, see, let's go back there, these two lines that we've drawn in yellow, the red and the blue, are equal, as you can see in the drawing that I've put there. They're equal to signs. Those lines are equal in length. So please be careful about that. Make sure that you understand it. Very, very easy to get that wrong. Now we're going to look at a cyclic quadrilateral. And before we get into the cyclic quadrilateral, let's talk about what a cyclic quadrilateral is. It's a big, ugly word. Cyclic. Blah, 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 blah. It doesn't roll off the tongue very nicely. But a cyclic quadrilateral, what does that mean? Cyclic, circle, and quadrilateral, 4. So circle, we have a circle, and we have a square inside. So if we go back to our drawing that we have over here in our PowerPoint, and we have a look, we can see that we have our circle, and highlighted in yellow. There's our cyclic, and our quad. There is our quadrilateral. 4 sides. 1, 2, 3, 4. And notice something very specific. The 4 sides are touching. 1, 2, 3, 4 are touching the circumference. So bear in mind, a cyclic quadrilateral will always have 4 points on the circumference. The only time that this doesn't apply is when the examiner expressively or says to you in the question that this shape A, B, C, D is a cyclic quadrilateral. And you look and go, but hang on, those 4 points aren't on the circumference. If the examiner tells you that the shape is a cyclic quadrilateral, you apply all the rules that we're going to go through now to that question. Don't look at the question and say, but I've learned before that a cyclic quad must touch all four sides must touch the circumference. If the examiner tells you it's a cyclic quad, it's a cyclic quad, and all the rules apply. So what are these rules? Well, let's have a look. A cyclic quad very simply says this, that the opposite interior angles, so these two angles here, are supplementary. Now what does this mean? Supplementary angles are two angles. If we add them together, angle 1 plus angle 2 must give you 180 degrees. That's what supplementary is. They supplement each other to get to the 180. In our case over here, what does that mean? If we gave you an example, if this angle over here is angle A, and this is angle B, angle A is equal to X. Sorry, that is a terrible color, ladies and gents. Angle A is X, angle B would be 180 degrees minus whatever X is or what angle A is. Please, again, matriculants, I've seen this before with marking. Matrics make the mistake and they don't make sure that their interior opposite angles are supplementary. They simply just try and work out something, get an answer, and when you add these two angles together, they're equal to 200, 300, 400 degrees, which is not correct. Please make sure that you apply the rules so that you can get the best marks possible for this section. Right, before we get to our questions, I just want to quickly go over some rules that I haven't put up in any slides. And the reason why I haven't put them up is these are rules that you should know by now. From grade 8, grade 9, grade 10, and we've just gone through most of our rules from grade 11. Grade 8, 9, and 10, do not forget your triangles. We have an isosceles triangle, we have a right-angled triangle, we have an equilateral triangle, a scalene triangle. All those rules that we apply to those triangles are extremely important. The main triangle that comes up in Euclidean geometry is the isosceles triangle. And why is that? Well, if I just pan back very quickly just to show you why. If we look at our arrow theorem over here very quickly, and I draw that radius out and that radius out over there. If I had to join those two lines over there, we now have an isosceles triangle. Why do we have an isosceles triangle? Because that radii and that radii, or that line and that line, are exactly the same length. A radius for a circle does not change. It stays the same. With that being said, That now means that we have some more goodies that we have up our sleeves that we can use. Because now we know that this angle here, if we had to call that angle x, would be equal to this angle here, which would be angle y. And the reasoning behind that is, it's because it's an isosceles triangle. So don't forget that. All your rules from grade 8. Also, your rules such as your straight line. Angles on a straight line equal to 180 degrees. Your vertically opposite angles, angles that are vertically opposite each other are equal to each other. Angles in a revolution. So if I go right round in a circle, those angles all added up together must give me 360 degrees. Please make sure that when you are studying for your finals, for your June exams, for your prelims, that you are looking at these basic rules from grade 8, grade 9, and grade 10. Why? Because you are going to lose easy marks, and I don't want you to lose these marks because you kind of forgot grade 8 and 9 work. Remember as well that in matric, 60% plus minus is grade 11 work. Bear that in mind. Don't just study what you've learned this year. Get your grade 11 textbooks from last year. Go through them. They are going to help you tremendously in your exams to come. Matriculants, just before we go, I want to remind you of something very important. Euclidean geometry is one of those subjects or one of those questions in the paper that a lot of us just leave out. Please don't leave it out. It counts for plus minus 40 marks out of your 150 mark question paper. That is for all June and your prelims and your final papers, 40 marks. That is almost a 30% or a third of your paper is Euclidean geometry. So please take the time, go through Euclidean geometry. Do not just leave it out and say, oh, this is too difficult. And as I said, matrics, we have come to the end of our lesson. You can leave your questions and your comments. And please don't forget to leave the name of your school that we can give shout outs to you. Please share and recommend and to subscribe to our YouTube channel. Thank you for watching, and we will see you in our next lesson when we'll be going through 2 very quick questions just to practice what we have learned here today.